Hey everybody. So today we're going to use an object called what tilde, as well as a handful of others that came out very recently with Max 8.3 to make a simple but very powerful MIDI sequencer that will play back this sound. Let's get into it. So we're going to start with a phaser, which is pretty much always what you want to start with whenever you're using these new objects, because they're made to work in tandem with phaser, and I'll show you in a second why. And then I'm also going to create a transport. Because I have this lock attribute set to 1, the phaser is going to obey the transport as its master timing mechanism. So when I start the transport, I get a nice wave. And 1n basically means that it's going to loop from 0 to 1 and back down, or ramp rather from 0 to 1 and back down every bar. If I speed up the tempo, which is in BPM, I can do that. So right now we're getting a ramp every bar at 120 beats per minute. And a beat in this case, I believe, is 4. And we can set that. I can't remember how that's set, but it's set somehow. But we know that that's the default. And that is fine with me right now. Okay. So the next step that we need to do, now that we have this idea of a bar, is generate sort of a step counter that's going to allow us to create events along this continuous spectrum. Anybody who's used a step sequencer in the past, perhaps on a drum machine, knows they usually have like a bunch of buttons with a bunch of lights, and they light up as the sequencer steps along. And we can create something that works just like that using a pair of these what tilde objects. And I'm going to pass the output of this phaser into one of those. And then I'm going to visualize what it outputs in the scope. And you can see here it's giving us this occasional little pulse. And that's happening each time this phaser crosses the value of 0. So it ramps from 0 all the way to 1, and then when it comes back down to 0, every time we get this pulse. And that's because what does is basically look for phasers to cross specific values. And it can look for multiple values too. So I can tell it, look for 0, 0.25, 0.5, and 0.75 for values. And now it's going to give me impulses at each of those points along the way. So we can think of these as our beats. We can think of these as basically being quarter notes that are being fired off with very accurate timing, by the way, along the course of this ramp. So we could imagine we could write a simple patch, which we're going to in just a second, that will allow us to input a number of steps and tell this what tilde object to output an impulse for each of those steps. So the way that we're going to do that is we'll first divide 1 by the number of steps that we want. So let's say it's 4, which is going to give us 0.25. And then we're going to create an Uzi whose base attribute is set to 0. And when we send a value, an integer, into the left inlet of Uzi, it's going to send out that many bangs very rapidly from its left outlet. But more importantly for our purposes here, it's actually going to send out a count of the bangs it's produced from its right outlet. And because we're using this base 0 attribute argument, it'll start that counting from 0. So what we'll do is we'll get 0, 1, 2, 3, 4, 5, and we're just going to multiply that, or 0, 1, 2, 3 in this case, because we have 4. We're just going to multiply that by our 0.25. And I'll print the output of that. So now we're getting 0, 0.25, 0.5, and 0.75. Because Uzi is outputting 0, 1, 2, 3, and it's always getting multiplied by 0.25. And so in order to make this useful to the what tilde object, all we need to do is pack those values into a list, which we can do with a ZL group object. And we're going to connect this second outlet of Uzi to the ZL group. The second outlet of Uzi produces a bang just when the banging is done. So when it's produced all of its output, it's going to give one final bang, and that will tell the ZL group to output its contents to the what tilde object. So if I set this number of steps to 16, now we're going to get 16 of those pulses. So what are these pulses exactly? Well, what they really are is a single sample at 1. So the what tilde object is outputting mostly 0 all the time, just 0, 0, 0, 0, 0. But when one of these thresholds is hit, it gives us a single sample at 1. So what we can actually do is just add up those samples of 1, and that will give us basically a count of the number of these impulses that have occurred. So a way that we can do that is with the plus equals tilde object, which is what we call an accumulator. And if I pass the outlet of what tilde into that, and then I pass its output into a number, we can see it's already begun counting all of these pulses that have passed. So now we're pretty close. The only thing that we have left to do is to tell it, hey, I don't want you to count, infinity to infinity. I actually want you just to count from 1 to 16 for the position along this ramp. So in other words, we want to reset the count when the ramp restarts, which we can do with a second what tilde object. This what tilde is in its default state, so it's only producing that pulse on 0. And the right inlet of plus equals tilde will reset its internal count whenever it gets such a pulse, which is very convenient. So now you can see that we're just counting from 1 to 16. So I'm just going to encapsulate this. And we probably don't need that anymore. Cool. Maybe we make this super small so we can still see it, but just not in our way. Great. Okay. So now that we have this step counter, the next thing that we need to do is be able to produce a list of MIDI node values and have those values be looked up, basically discovered by the step counter so that they can be sent out to the synthesizer. So the first thing I'm going to do is actually create a multi-slider. And I'm going to have 16 sliders, and I'm going to set its range to 0 to 11. And so you can see that when I twiggle with the multi-slider, I get a bunch of numbers between 0 and 11. And because we're dealing with MIDI here, I would like, first off, to convert this number to an integer. And then second, I want to offset it some amount. So rather than having 0 to 11, I want to have maybe 36 to 48 or 36 to 47. Cool. And in fact, we could do something kind of tricky, which is if we break that process up into stages by using first a vexper int f1, all this does is turn this list of floats that's coming from our multi-slider into a list of integers. So taking all the decimals off. And then we can prepend that list of integers with the symbol setList, which will tell the multi-slider to snap to the exact point, which is kind of convenient. So instead of having, even in the multi-slider, instead of having everything on floating point numbers, we can see more clearly what's actually going on. And then that value is just going to get added again to 36. So now we're getting a bunch of MIDI note numbers that are, the type of MIDI note numbers that we can actually hear. Okay, so now we have that list, and now we basically need to make it so that that list is available to our step counter. And to do that, we're going to use a really cool new object that also came with Max 8.3 called Stash, which can do a ton of stuff. And I will be honest, the help patch is a little bit bewildering in my experience, but it's pretty straightforward, I think, once you wrap your head around it. So what Stash basically allows us to do is store a bunch of numbers and recall those numbers with audio signals. So I'm going to say stash ed mode 1. And ed mode 1 is basically how do I want to read back that data. So what I'm going to do is just simply pass this list into the first inlet of Stash, which is going to allow all these numbers that we have here to be stored in there. And then into this third inlet, I'm going to pass our step counter, which is an index basically of the position of that number. This works a ton like ZL lookup, if you've ever used ZL lookup. So if I do the same thing, I pass a list into ZL lookup, and then I give it an integer into its left outlet. It's just giving me the number at that position. This is basically doing the exact same thing. But what's really nice is that it's actually doing that with signals rather than with ordinary max events. And the reason that that's valuable to us is simply because we're going to get a little bit more solid timing when we work with signals. That's really one of the big benefits of all of these new 8.3 objects, is that they make doing things like sequencing very easy with signals rather than having to rely on traditional max objects to use these gray patch chords. So you can think of Stash as being like a ZL lookup on steroids, basically. So if we connect a number box to the output of Stash, we can see that we're getting these values output. So that's going to be our MIDI note. Let's do the same exact thing for the velocity. We're going to remove this offset, and we will change the min-max to a range between 1 and 127 because it's a velocity. And it's actually kind of nice to be able to see what we're getting out here, so I'll leave those. And again, those are floats, so we're converting them to integers, so I'll actually connect this here. There we go. Very nice. And then now we're kind of at the point where it makes sense for us to leave signal land and convert into normal max integers and floats, because our MIDI object that's going to receive that data doesn't accept signals. So to do that, we can use the snapshot object. And there's two ways to get snapshot to convert a signal into a regular floating point number. The first is to give it an argument, which is some number, which is basically saying every n milliseconds, take the current value that's being received at the signal input and report back the value. And that's a fine way to work. Although in this case, we know more precisely when we're going to want it to sample, which is basically every time this value changes, right? We don't really want it to sample more often than that because it's just making our computer do unnecessary work. And we don't want it to do less than that, obviously, because it's going to miss things that we want to be sent on to our synth. So what I'm going to do instead is take away that argument, and I'm going to send the output of the stash object to a change object, and then I'm going to take the absolute value of that. Actually, I don't even need the absolute value. I'm just going to pass it into an edge object. And what's going to happen then here is every time this value changes, we will get an impulse either above or below 0, which doesn't really matter. Every time we get one of those impulses, edge tilde is going to turn that into a bang, and if we bang our snapshot, it's going to output the value. So this is basically just a little bit more of a clean and efficient way to get Snapshot to do signal to float conversion without needing to, basically only doing it exactly when we need it to. So we're going to do the same thing on this side. And we need to pass our counter into stash as well. Great. And then we will pass that into a make note. And we'll say we'll do like 100. So 100 milliseconds. So make note is pretty convenient. It allows us just to send MIDI note and velocity, and it will automatically generate the note off, MIDI note off event for us after a set number of milliseconds, which in this case is going to be 100. And then if we take our note out object, I'm just going to get rid of this for now. We now have a sequencer. And I can make it quiet. Although it doesn't sound like my synth patch that I have running right now really cares about velocity, but if it did. Oh, it does. It does. It's just not very responsive. You can see it's a little louder. Now it's quiet. Cool. And I can obviously change the pitches. Let's clean up a little bit. So that's basically it. I think there's probably one more thing that we might want to do. Oops. And I'm just going to stop things for a second here. So now we can turn it on and off. I think there's probably one more thing we want to do, which is basically make it possible to have rests, right? Because right now we're just, we just have this constant stream of 16th notes in this case at 120 beats per minute and just constant notes. So it would be really cool if we could kind of have like classic step sequencer style buttons that would, turn on and off those events. So let's do that. And I'm actually going to do a tiny bit more cleanup as well. This is going to be a parse list, let's say. And I think I need to send it again because when I did that, there we go. Great. Cool. So in order to create our little step toggler, let's call it, I'll use, let's say, matrix control. Rows of 1, columns 16 in this case. And actually, we're going to want the number of these columns, or the number of these steps, to be dynamically adjusted with how many steps are actually in our sequence. So we'll pass this number of steps into this columns or message box that will tell the matrix control how many steps to create, so we can change that. And we can and probably should do the same for the multi-sliders here. Cool. So if we said 8 or 16, it intelligently resizes for us. Cool. Okay, so with the matrix control, when I click something, I'm going to get something out of this left outlet, and I actually don't care what that is because I'm just going to use it to get the entire contents of the row, like so. So I'm just using that stuff it outputs from its leftmost outlet as a bang, basically, so that it sends a get row message back to the object, which causes it to output its little sequence here out of the right outlet. And then I'm going to do the same thing that we did before. So we'll say with the stash. So we'll say list funnel. Actually, we don't even need list funnel. I'm thinking of a different method. So stash. Pass that list in at mode 1 because we're going to be passing an index in here. And so now we're getting a 0 or a 1, and then we're just going to put a gate in between our step counter and our note and velocity devices. Oops, now I'm confused. Hold on. These are the ones we want. Great. So you can see this is what, I know we're a little messy here, but bear with me. This here is what the step counter is outputting. But with the gate, this 0 or 1 that comes from our stash. Now it looks like I have this set up wrong. One moment. Can open and close that gate so that we only get some of those events through. And that's going to allow us to have rests. So that's that. MIDI sequencing with what tilde and stash. Happy patching.